Hi guys, in this video I'm going to explain about Klaw, a very useful toolkit. You are going to find it. But before that, let me give some background about Kafka itself, because Klaw is developed for several organizations who are actually using Kafka and facing many challenges, I believe. As most of you all know, Kafka is widely adopted in many organizations because of its unique features like scalability and retention, and making it apart from any traditional messaging platforms. However, adapting Kafka comes with a few share of challenges. And in this video, we are going to see how Klaw is helping these organizations tackle these issues worldwide. Nowadays, many companies include Kafka in their technology stack. I think most of you all know that, because it enables them to grow and scale effectively. Kafka serves as a messaging and streaming platform similar to other messaging solutions, right? But with its exceptional features, it makes it stand out. Now, how Kafka works: events are published to Kafka and they are stored into topics. Topics have partitions and partitions have offsets, and finally the events are stored in offsets. Now let's look at the actual problems, because topics have authorizations, which means the producers and consumers need to get access on these topics. And managing these authorizations is a very big struggle, I should say. Large companies have hundreds to even thousands of topics, and the improper governance and the authorization around them, managing this is a very big headache. To address these challenges, organizations have to rely on some external products, or they have to develop some internal frameworks which have the capability to store this metadata. So it could be either Confluence, Git, or Excel. They could use any of these projects. And we are going to look at these problems in detail now. And here we are seeing a typical Kafka environment. It has a schema registry, it has topics, and there you are seeing producer teams and also the consumer teams trying to access the topics. Now let's see some of the problems in detail. Let's take the use case of creating a topic. A producer team is going to request for a topic from the infrastructure team, right? Assuming that infra team is going to actually create the topics for them. Now producer team is going to request for the topics, and there is an email communication back and forth after the confirmation. Now the consumer team also wants to consume the data from this topic. Now the infra team has to send an email to the producer team that, hey, there is a consumer team who wants to get access on this topic. Is that okay for you? And then they'll say yes. And after that, they are going to give the consumer access. If you're seeing here, there are several email communications happening. So for a single topic creation and giving the producer and consumer access, there must be at least 10 email communications. This could span about 2 to 3 hours at least, excluding the non-human response time. You might have also noticed there are several security issues around this. I should say, who is actually executing the command? Is the producer and consumer team, or the right teams who are actually requesting for the topics? So basically, there is no record of who executed the command. And this is all about ad hoc governance. Centralized governance is a challenge here, based on the actions, whatever is happening from these email communications. Let's take another use case of promoting the topic from lower to higher environments. We have to really make sure the topic name, its configuration is properly promoted across higher environments, right? If this whole process is properly automated, it's fine. Otherwise, you would have to expect issues there. Now let's look at a bigger picture. Various questions come in the context of Kafka implementation. Who is actually owning the topic? Who is the owner of a schema? Who is allowed to produce and consume from a topic? Who are the owners of the Kafka connectors? We are really thinking about topics where there are thousands of topics, and whenever some change has to happen on them, we really have to make sure that the configuration change is being requested from the right person, right team, and also being executed by the correct person after the review process. And another important thing is, are the topics being promoted from lower to higher environments seamlessly with all the tested configurations? I should say that these challenges are not visible in the initial stage of the project. As the application and the project grows, number of topics increase, and the authorizations, teams, people using these topics, everything grows, right? And that's when you would start to notice these problems. And keeping all these issues in mind, Klaw was developed. So what is Klaw? Klaw is a toolkit, and it's a web application designed to automate the process of creating topics, ACLs, schemas, and connectors. Klaw is based on 4 fundamentals: governance, self-service, security, and automation. Let's look at them step by step. Governance. Governance involves defining of roles and responsibilities, ownership, auditing activities, and naming conventions, to name a few. And very importantly, Klaw acts as a single source of truth, preventing any sort of manipulations happening on the clusters. However, Klaw can also identify any manual changes happening on the cluster and notify the administrators about that, and synchronize across the systems. We all know self-service empowers the teams to become very independent of the infrastructure teams and also manage all the Kafka configurations by themselves. They can create, promote, edit, and provide producer and consumer access, and also request for connectors and schemas themselves. Now let's look at security. Users can log into Klaw with their Active Directory credentials or any third-party providers like Google, Azure, or GitHub, or any other single sign-on provider mechanisms. And coming to the connectivity between Klaw and Kafka clusters, Klaw supports all sort of protocols whichever Kafka is supporting, like Kerberos or SSL, and also plaintext. And the last and the most important one is automation, because it enables easy provisioning of configurations and allows a smooth promotion of topics across different environments. One important thing I would like to mention is about the metadata on Klaw and the actual data on the Kafka cluster. It can be synchronized at any point of time. Metadata on Klaw can be synchronized back and forth from Kafka clusters to Klaw or from Klaw to Kafka clusters. Now that we have seen the fundamentals, let's take one use case of creation of a Kafka topic, how the user journey flows. Here, John requests for a Kafka topic with certain number of partitions and replication factor, or also maybe advanced configuration, and Mark reviews, and let's say all the configuration is all good, and then Mark is going to approve the topic. And on approval, topic is created on the cluster. That's it. Same principle is also applied for schemas, connectors, and also ACLs. Every topic has an owner, and all the requests coming on this topic, like it's a producer request or a consumer request, it's the topic owner team which has to approve the request. I have a very interesting image for you where most of the Kafka developers find it very insightful. This is the dashboard of Klaw, displaying the ownership of topics, how many are producing, consuming, and what are the pending requests on all the components. At this stage, most of you would be thinking, does Klaw fit in your project? Is Klaw suitable for your project? Klaw is an open source solution based on Apache license, and you can download it for free and deploy into any of your environments, dev, test, or accident suppression, or any environments. It basically consists of 2 Java processes and is also available as Docker images. And the good news is, you can deploy this in your production environment in high availability mode. Coming to the user interface, we are currently developing a React-based UI where our users are finding it very, very user-friendly. And finally, the project can be downloaded from Git repository, or you can download it from Docker. I have a few useful links here, and if you have any sort of technical questions or any questions about the project, please raise a Git issue on the Git repository or send us an email. This is all about Klaw. Thank you for watching and hope you have a good day.